So one that I wrote down about the game itself, it's not a perfect comparison, but the variations of the game of chess are like the variations in programming languages because you consider that the game that most people know as chess is actually like one of many, many types, and there are other variations, some that are well known, some that aren't. And it's the
Hmm.
same with programming languages. Like, JavaScript might be one of the most dominant programming languages, but you also have Python. Chess that
Okay.
we play might be the most popular, but Chinese chess, bears resemblance to the game and is still, pretty popular in
Oh,
certain parts of the world.
there's also
Yeah.
chess variants, three check chess, where if you win by checking your opponent three times, or king of the hill, where
Hmm.
if your king goes to the center of the board, then you win without getting checkmated first. Variant.
Variants.
There is actually one that's like an ancient variant of chess. It
That's
has
like the
a
C programming language.
yeah. Oh, there's atomic chess where if you capture a piece, both of the pieces explode, and also it'll kill any other piece that's on a adjacent square.
That
So
sounds wild. Can you
uh,
can you click on historic?
this is the one I was thinking.
Chaturanga.
Chaturanga.
Chaturanga. Yeah.
Chaturanga is where the bishop is not called a bishop. I
Yeah.
forget what it's called, but the
I think
bishop.
it's the elephant.
Oh yeah, yeah, yeah. The elephant, it still moves in a diagonal, but you can only jump two squares diagonally. It doesn't matter if there's a piece on the middle square, you skip over it, and it always has to go the same distance. You can't go farther or closer than that.
I guess the last thing I'll say about this topic, just especially with emphasis on the historic, is like I've always thought it was very interesting in programming languages how concepts we take for granted, like object-oriented programming or like paradigms, like you can trace them back through history to like earlier programming languages. And similarly with chess, you can trace like the evolution of the game from like Chaturanga or then like how it evolved in the Renaissance, like when the queen became a more powerful piece into like the
Mm.
modern game that we know today. Just like these little tweaks and optimizations over like a lot of playing or usage and a lot of time.
Hmm.
And now like we in the modern day have like pretty great versions of chess and pretty great programming languages to work with.
I also think that can be said about the chess openings, actually.
Hmm.
So the most famous opening is probably the Ruy Lopez or the Spanish opening.
Which is so old.
Yeah, it's extremely old. And actually, there's this channel called Agameda that I
Mhm.
watch. He just covers chess games, and he will tell you about the age of the particular game that he's showing.
Oh,
Like
that's super cool.
he covers like very old games, like between Paul Morphy and Adolf Anderson. Like back then, they started playing this style. There's the Morphy's defense reply to the Ruy Lopez, for example. That was invented by Paul Morphy, and then Anderson has a variation on top of that. There's these very well-known openings. There are some less well-known openings as well, and
Hmm.
also for the well-known openings, there's also the main line where the most people traverse those main lines, whereas the sidelines are the less used variations. At the top levels of chess, because everybody knows the main lines really well at the top level, they have all these things memorized already. In order to surprise your opponent, you have to play something that's not often played.
I'm curious, can you draw a parallel with that concept to programming?
In programming, what might be a sideline?
Maybe some like obscure trick.
Yeah, it could be an obscure programming language or a more obscure framework. Some things that start off as a sideline, they become the main line if they gain popularity. So like RxJS initially started off as this weird thing. I remember seeing RxJS being shown off initially. Somebody was using it to program like a platformer game, sort of like Mario Brothers. Later on, it became popular when, like, especially Angular embraced it. Elm is, and before Elm, there was ML, Haskell, Lisp, Smalltalk as well. Smalltalk is like an older thing that has this property, I think. Elm might be the modern day Smalltalk. The willingness to stand out as the weird thing. You're not similar to any other thing. You're extremely different from the most popular things out there.
Mm-hmm.
And you're not ashamed of it. You're just proud of being that singular thing. Have you ever seen small talk code before? Nowadays, pretty much everybody has gravitated towards this C-like syntax. If it doesn't look like C, people think nobody's going to use it. Maybe that's not the prettiest example. Hello world index of starting at 6. Whoa, what's going on there? Well, this is a string. This is the method of the string that we're invoking. And the method has two parts. It's called index of something start at something. The method name is not just one continuous string, but it's a sentence with placeholders inside the sentence. That's what methods are in Smalltalk.
Interesting.
It's just wildly different from normal. And I think Elm is like that for the present day. One thing I want to say is the existence of improbable solutions. Yeah, this is one of the most famous chess games ever played between Paul Morphy and two people, Duke Carl and Count Isouard. It was played while they were watching an opera. So this is the punchline. There's a mate in 2 in here. Do you want to try to find a mate in 2?
Oh boy. Is it white queen take e6?
Queen trait? No. The solution is queen to b8 with check, sacrificing the queen.
Yeah, you have to take it.
And then there's this checkmate to d. And then
very slick.
The king can't go anywhere because this whole file is guarded by the rook, so it can't go here. Can't go here because there's bishop here. This is sort of like a standard checkmate pattern with the bishop on the diagonal and the rook here. But the kicker is that you sacrifice your queen to open up the knight, so the knight is not blocked. So now you can get to do this checkmate. This is like a seemingly improbable solution. In chess, we really celebrate this kind of checkmate. Do you think it's fair to say in programming we celebrate improbable solutions as well? Like this, is that something that resonates with you?
With me, yeah. I mean, I can say if you're talking about ways of solving problems, like there are just some solutions that are so clever. I'm really impressed.
Yeah. Can you think of one offhand?
I was digging into binary tree traversion recently, like depth first versus breadth first, and then like even within those two types, what is it called? The variations. What are they like? You know, where you
pre-order, pre-order, post order, in order.
I thought it was really fascinating that when you do it in order, it's exactly what it sounds like. You print out the list in order.
In order, yeah.
I was like, that is remarkable.
Like you just accidentally got there out of nowhere.
Yeah, because you could have done, I mean, like you check yourself, then check your left child, check your right child. You check your left child, you check yourself, you check your right child. Oh, all of a sudden, the whole list is in order.
I remember giving a lecture about merge sort, the merge sort algorithm. Step 1, you break the array into 2 halves.
Mm-hmm.
Step 2, you sort both halves. And then step 3, you merge the 2 sorted halves. And that's the algorithm. And then in particular, the part that I would explain is the process of merging 2 sorted arrays into a single sorted array, right? Well,
Mm-hmm.
I already know that these 2 arrays are sorted. They've been pre-sorted because I did that in step 2. Now I'm going to show you an algorithm that will merge it into a single sorted array. And it has to do with walking the pointers on both of them. And then at the end I said, and that's the algorithm. Any questions? And then somebody said, and I knew they were going to ask me this, but they said, yeah, but how do you get the 2 halves sorted?
Don't you run it again?
That's recursion. And that's the part that blows their minds. There's like, you use merge sort to sort the 2 halves.
Yeah.
A lot of them that are being taught this the first time, and they would try to answer it. Oh, okay, you use another sort algorithm to sort it. Like it's too much for them to take in the concept of recursion. That is just like a mind bending. Recursion is still mind bending.
Yeah.
You can apply it to many different contexts. Whenever you approach a new problem, whenever I do, it's pretty mind bending. You have to put you into this mindset that if I tell it to do this thing based on myself, I just have to trust that it's going to do the right thing.
Yeah.
And that's really hard to conceptualize when you haven't even written the thing yet.
I like that point. There are definitely like incredible moments in both mediums. I wrote down a point that's related to that.
Mm-hmm, mm-hmm.
So it's basically what I wrote is established algorithms for the most optimal ways to do something exist both in programming and in chess. For example, checkmate with two rooks or like checkmate with two bishops versus like pathfinding and sorting in programming. There are like very concrete things where it's to the point where, you know, I'm sure it was like a very clever or time consuming process to figure those things out. But now it's like you can stand on the shoulders of giants and like go reach for Dijkstra's algorithm, or you just memorize the pattern for how to like checkmate with two bishops. And if you're ever in that situation, you can execute it. Two bishops is tricky. It's really tricky. At one point on chess, I was doing those drills, and that one I had to look up how to do it because it was really hard.
I didn't even know you could checkmate with two bishops. Wow. The ones that people learn is the checkmate with two rooks.
Queen and a king.
Queen and a king. And
rook and a king.
Yeah, those are the easiest ones and most straightforward ones. Rook versus a bishop. That's like an extremely hard problem.
Yeah.
Like there are some cases where there's a draw, but there are some cases where there's a win. Like the checkmating pattern with a queen and a bishop, or the checkmating pattern we just saw with a bishop and a rook, or a knight and a rook in like a specific positions. If you memorize those really well, you can really leverage that.
Yeah. And those are algorithms, and some of them are like rote memorization or you look them up. And then there are also like in both mediums concepts that are good to know about. Like, I don't know, in programming, maybe like using a hash map to manage data. And in chess, it could be something like control the center. Like these kind of like fundamental ideas, like are tools to have in your toolkits, you know, but there might be many situations where it's appropriate to apply.
Yeah. In chess, they would call them principles.
Yeah.
Versus tactics, maybe.
Yeah, exactly. And so principles in programming too, it's like try to write pure functions.
The solid principles.
Yeah. Yeah.
Yeah.